Hi, I'm Alan Ross. I'm here at the IEEE PES T&D, that's a lot of acronyms, conference. This is the 2020 version that is actually being held in 2022. These interviews that we're conducting is with thought leaders on the future of the power industry. So enjoy. So our next guest is Dr. Nathan Jacob. I call him Dr. Jacob, and he said, call me Nathan. So Nathan, thank you for joining us. I appreciate it.
That's my pleasure, yeah.
Okay. So you are in charge of a part of Camlin, and you work under Dr. Marco Tosi, who is a dear friend of IEEE's and of APC Media, done a lot of different things. How long have you been with Camlin?
You know, very recently, so just about 5 months now. So,
okay.
Yeah, very, very recent acquisition.
I probably know more about Camlin than you do.
Well, we could shift chairs here and do the interview the other way.
You interview me. Ask me about Camlin. No, I really want to talk about the future of where's the industry going? What are the big challenges as it relates to the power industry in North America? So that's Canada here. You can go global if you want, but particularly what's taking place in North America. What do you think the trends, challenges, or changes are?
Yeah, I mean, obviously the big ones that so many talk about, you know, electrification of transportation is a big shift, and the direction that we're moving there with electric cars and buses and trains. And then also, you know, trying to get to, you know, net zero, like decarbonization, so removing a lot of the large use of fossil fuels, and for some, you know, especially in Canada, heating, most of our heating is natural gas, so reducing emissions on that front is a major challenge. So
let's go into them, because you hit transport. It's easy to say electrification of transportation is going to change things. How is it going to change things? What is the impact on the demand, whether it's on the consumer, whether it's on the utility?
Yeah, so I mean, trying to reach net zero, like you know, for nations to reach that endeavor, it's going to be a big challenge. For example, you know, heating in Canada with cold climate, natural gas heating is kind of a necessity. So in Canada, the pressure to harness that much more in renewables to offset that difference is going to be, you know, all that much more challenging. And with the use of renewables and the increased use of renewables, that imposes other stresses on the grid, on the electrical grid. So, for example, load cycling and cycling to accept the renewable energy units that may have been generating units and transformers that may have been base loaded or just loaded at a fixed level, may find themselves having to be cycled to accept that renewable. And those changes, that cycling, that imposes new stresses, new factors that would increase or accelerate the aging of equipment, and then there's other you know, stresses related to just the renewable energy imposing some things like harmonics or other voltage distortions.
Voltage transients.
So there's a whole slew of new stresses and issues that you know, as this grid is changing, as the network is changing, you know, we have to look at the equipment closer, examine it, monitor it, to see how these stresses are affecting the equipment over time and its reliability.
So I would venture to say, you use the word monitor, I'd venture to say at this conference there are probably 20 or 30 companies saying, buy my stuff, buy my monitor. Interoperability, the ability for having a connected system, is another big buzzword that's taking place in the industry. And too many of these systems are side systems. How do you see that happening in the future? How do you see people buying the 20 different things, but at the same time making them interconnected?
Yeah, so I mean, the technology has changed. So like the availability for technology and the interconnectedness and communications, it is a lot better. And also the interpretation of the data with the improved technology, the ability to, you know, not just acquire a singular parameter, but also to look at that parameter and how it's related to the other parameters associated with, let's say, monitoring a transformer.
Okay.
So, there's many parameters, and I think historically people looked at, offline testing as a way to extract singular parameters and then look at that parameter to inform them whether something is degraded or overstressed. But now, the pressure is to keep equipment in service online and running, and the ability to, with monitoring, to analyze multiple parameters and multiple data at the same time to do these kind of correlated analysis of the degradation mechanisms.
Right.
It's very powerful, very useful, I think, for the future to harness that now.
So how is Camlin, what are you all looking at in the future? Where you are now, what are you looking at the future to take either advantage of the changes or to mitigate the negative parts of the changes? Where are you going as a company?
Yeah, so one of our mantras is to be a partner to utilities, to users, to industrial customers, and a partner for the grid of the future. So
right.
Exactly as we're talking about the stresses and the changing network and the changing grid. So, but we've assembled a good team. My own background, I'm a test engineer, so I have a background with diagnosing transformers in the field and operation, as well as doing testing in a test lab. But we also have transformer experts. We have people who are experts in testing and measurement and diagnostics. We have transformer experts. So we're not looking at data as just singular parameters that we're going to look at patterns and trends in with time. But with the expert eye and the knowledge and the team that we have, we're focused on really identifying which parameters are of importance, which parameters are correlated, and how we can make decisions, connect that data to decisions, in an intelligent way that's going to, protect the assets and be what's best for our customers.
So people are an important part of Camlin's future. It sounds like having the people that can partner with the utility to say, here's the data, but here's what it means. Right? And that's one of the big things in legacy knowledge that utilities are losing, because that generation is leaving or has left. COVID just fast forwarded it, right? There's a lot fewer of them there. So it's significantly more important to have people that can help interpret data. That's the last thing on the future I want to talk about. More data is being created every day. How that data is interpreted and used is critically important. How does Camlin help in that area?
How the data is interpreted?
Yeah.
So, we've been collecting data, so we're not new to market, and we've been, kind of a leader in, monitoring systems and intelligent diagnosis of the data. So, very much so, we have a focus on looking at correlating indicators. So indications in the assets that there is a problem, and we try to correlate either multiple indications of a problem, so an internal problem inside a transformer, or correlations that may be associated with the operating conditions.
Okay.
So from a user's perspective, that gives important information about how they can extend life, or how they can operate their assets into the future.
Okay.
Yeah.
Last series of questions I want to talk about IEEE specifically. You've been around it, you've been a member of it, you've been on committees. Talk a little bit about the value of IEEE. I consider you the next generation. I want you to talk to your next generation. Why should companies have their engineers involved? Why have you been involved?
So, I've been involved. So from the user, the asset owner's perspective, it's important because we're talking about stresses on assets into the future, and that changing, the network changing, and involvement through IEEE is a way to affect how assets are specified, what the rating should be for these future stresses that we're expecting into the future. So from that perspective, it's valuable. And then also just from a technical enrichment perspective, the shifting demographics, like you talked about, one wave of engineers are leaving the work environment, and there's a lot of young engineers who are coming in with a growing network, facing that much more complexity, but also just the network is growing and integrating new technologies, green energy and electrification of transportation, these items we've talked about. So from a knowledge development standpoint, but also the point of view of influencing what's in those standards, what's how the equipment should be specified to ensure that reliability. So,
yeah, excellent. Thank you so much. I appreciate your time with us, Dr. Jacob. Nathan, thank you.
Thank you.